So I promised you a video on the proofs for the logarithms, and never take my word for it until I've shown you something worth proof. Yeah, worth proof. Yeah, that makes grammatical sense, I guess. There, I mean, it's grammatically correct. Whatever. We're gonna be proving, in this case, in this video, the first logarithmic law. The first logarithmic law. And let's try and recall what the first logarithmic law is. It went a little kind of like this: log to my base a of b, right, plus log to my base a of c is log to my base a of b times c, right? That's what our first logarithmic law is. But the question is, how do we know this is true? How did somebody just come up with this? How do we know that this is always right? And that's what we're gonna find out. Now let's say I had two values. Let's say we had y and we had x, for example. Both of which I can express as where I can express at a raised to a certain exponent. Let me just clarify what I mean. Well, I can say y is basically a to the power b. So y is a value where which can be expressed as a raised to an exponent, and let's say x is equal to a to the power m. That should do, right? But before this, I want to see if I can re-express these as logarithms. Can I re-express these two values as logarithms? The first one I can. Let's look at that. I can write log to my base of a, which gives me y is b. And here I can write this as log to my base of a, which gives me x is m. And all I'm saying here is, let's try and recall, the power that I raise a to give me y is b. And here, the power that I raise a to give me x is m. And that should be clear based on the previous video. So let's progress and let's see. I want to try a little bit of fidgeting with some of these values. I want to see what happens if I get y times x. If I multiply y by x, well, I know y is a to the power b. And I also know that x is a to the power m. So y times x is basically ab, right, times a to the m. And based on my indices, this is simply a to the power b plus m, right? So I can just simplify this and write that yx is equals to a to the power b plus m. That's all I've done. Now, there are two things I can do here, and I want to go with the more mathematical and rigorous way first, and later on I'll show you the other intuitive way. They're basically more or less the same, but let's see. You pick whatever you like best, so you know whatever you want to understand best, whichever you understand best, right? So let's say that I want to rewrite this. I want to say I don't want to write a to the power b plus m. I don't want to write a to the power b plus m. So I want to say b plus m is equals to z, all right? Because I want to just congest this into a smaller number, a smaller value, one single value. So what I'm saying is, now if b plus m is z, right, then it's reasonable to assume that y, well, not reasonable to assume, it actually is, that y times x would be a. Now instead of b plus m, I'll just put z in that position, right? That should make sense. Now I want to try and express this as a logarithm. Well, what I can do is I can write this as log to the base of a, which gives me yx, all right? The base of a, which gives me yx, is z. Now what I'm saying here is a is raised to the power z to give me yx. The power that I raise a to give me yx is z. That's all I've said, right? But remember this. We just said z is b plus m. We just said z is b plus m. So does that not mean that log to my base of a of yx is equals to b plus m? It absolutely does. That's exactly what it means. And now that we agree on this, let's go back up a little bit. I want to scroll back up a little bit. Look what we have here. Oh, this is some little magic out here. We have log to the base a of y as b, and we have log to the base a of x, which is m. Now here we've got b plus m. All we got to do is substitute the logarithm versions of these numbers, of these values in. So instead of b, we'll write log to the base a of y. And instead of m, we'll write log to the base a of x, just like this. Well, I know log to the base a of yx is equals to, well, b is log to the base a of y. Log to the base a of y, right? And m is log to the base a of x. Log to the base a of x. And notice what we have here. This formula looks very much like our first one. In fact, I don't want to rewrite it. I'm just going to drag it up and show you exactly. Have a look at this, right? And have a look at that. This right up here. This right up here. They were exactly the same thing. The b and the c's multiplied. The log a's remain the same, right? When the logarithms are added in here, we got log the a base of a of y plus log base a of x. When added, just give us the product of the two values in here. But if for the other intuitive way we can do is, well, we can sort of skip all of this. We can skip all of this, right? And just come back to where we had stopped, right over here, where yx is equals to a to the power b plus m. Let's just rewrite this down here. In fact, let me change the color so we can clarify that there's a sort of difference. Well, yx is equals to a to the power b plus m. What I can do here is I can take the logarithm to both sides. You know why? Well, remember, with equalities, our rule is what you do on one side must be done to the other, just like in algebra. If you add 5 to the left, you must add 5 to the right. So if I take log to the base a of what's on my left, which is yx, this should be exactly the same as saying log to the base a of a to the power b plus m. And it makes sense because I know yx is a to the power b plus m. So I'm just expressing them two different ways, right? That should be clear. Now let's have a look at this bit over here, this little bit on the left side, this little mess over here. And you're probably wondering, hey, how I got log a and I've got a, what am I going to do about this? Well, let's try and see what this expression means. Let's just write it down here. Let's see what it means. Log to the base a of a to the power b plus m. Well, what we're asking here is, what is the power that I raise a to give me a b plus m? What is the power I raise a to give me a b plus m? Well, that's just b plus m, right? That's just b plus m. So instead of writing all of this, I can just say this is equals to b plus m, because that's the power which I raise a to give me this value. And we agree with that. So this is just basically b plus m is log to the base a of yx. And this is a more intuitive way, though it's harder to understand. It sometimes can be a little tricky to understand at first. I like to think of it like this. And remember how we have b plus m? Well, log to the base a of yx. Instead of writing b, I can just write it as log to the base a of y. Instead of writing m, I can just write log to the base a of x based on what we had collected over here. Log to the base a of x is m, and log to the base a of y is b, right? So again, as you see, we've arrived to the same conclusion, and I hope this proof makes sense to you and you're satisfied knowing how we come to this equation and why we use it and why it should make sense. As always, please look forward to studying more proofs, and it helps you get the math better. See ya.